Welcome to lecture 8 on circles. So in the last lecture we had derived the expressions for the equation of the common tangents to any two given circles. So in this particular lecture we will solve some problems on that topic, and then we will quickly move on to a new topic, which is basically defining something which is known as the angle of intersection between any two given circles. We will also derive the equation of the common chord of two intersecting circles. So let us quickly start with some problems on the topic that we discussed in the last lecture. So let us see this question first, where it is asked to find the coordinates of the point at which the circles, so we are given two circles. This is the equation of the first circle. So x square plus y square, x square plus y square minus 4x minus 2y plus 4 equals 0. So this is the first circle, and the other circle is given by has equation x square plus y square minus 12x minus 8y plus 36 equals 0. So we are asked to find the coordinates of the point at which these two circles touch each other. Also find the equation of the transverse common tangent of these two circles. So the problem statement is very clear. We have two circles and it is said that they touch each other, and in that case we are asked to find the coordinates of the point where they are touching each other, and then further we are asked to find the equation of the transverse common tangent between these two circles. So to illustrate this, let us try to do this geometrically. So let this be the y axis and let this be the x axis. This is the origin. So the first circle, which is this circle, this clearly has a center which is at 2, 1, because this particular term is plus 2gx and this is plus 2fy. So g is minus 2, f is minus 1, and the center we know is at minus g minus f, which is 2, 1. So we will denote this circle by C1. And the radius is of course equal to g square root of g square plus f square minus c. So, that will be, so for this we know that G is minus 2, F is minus 1, C is 4. So, this will be minus 2 square, which is same as 2 square, plus 1 square minus 4. This will come out to be 1. So, given the center and radius, we can plot the first circle. So, the center is over here and the radius is 1, and so since the radius is 1, the circle will appear something like this. Similarly, we can show that for the second circle, the center will be at 6,4 and the radius will be 4. So, this is the center of the second circle, and as the radius is 4 units, the circle will be something like this. Similarly, on this other side, which I am not drawing, then at least geometrically it appears that they are intersecting, it appears that they are touching each other at this point, but it is also not very difficult to verify that. So, if the circles, if two circles are touching each other, then it must be true that the distance between the centers has to be equal to the sum of their radius. So, the distance between these two centers is equal to square root of 6 minus 2 whole square plus 4 minus 1 whole square, which comes out to be 5. And if we remember, the radius of the first circle was 1 and for the second circle was 4. So, when we add them up, the sum of the radius is 5, which is exactly equal to the distance between the two centers of the circles, which means that these two circles are touching at exactly one point. So, this is the line joining the two centers. So, we were asked to find out the coordinate of this point where these two circles touch each other, and that is not very difficult, because suppose let us say that the coordinates of this particular point where they intersect is x y, then it is clear that this x and y must satisfy both these equations, because this point lies on both the circles, and since it has to satisfy both the equations, it must satisfy the difference of the equations also. So, what I mean to say is that because these coordinates of the point of contact of these two circles x and y must satisfy the two equations, the equations of the two circles, which are as follows. And therefore, if we subtract it, then what we get is so this point x comma y must also satisfy this equation, or we can simplify it to 4x plus 3y is equal to 16. This, in fact, this equation is, so it must be satisfied by This equation must be satisfied by this point. Now, we know that the equation of this particular line joining the centers is known, and we know that this point x y also lies on this line joining the centers, and therefore, it must be true that, so the slope of this line is equal to 4 minus 1 divided by 6 minus 2, which is 3 by 4, which must also be equal to y minus 1. So, the slope of this line must be the same as the slope of this line segment, because essentially they are segments of the same line, y minus 1 divided by x minus 2. So, therefore, the coordinates x and y must also satisfy another equation, and this equation we can write it down is 3x minus 6 equals 4 by y minus 4, which is, so essentially we have 3x is equal to 4y plus 2, and then we just need to solve these two equations. So, by solving these two equations, we will get the coordinates of this particular point here, and that is not very difficult. So, what we can do is we can multiply this equation by 4, we multiply this equation by 3, we get 9x is 12y plus 6, and then we add these two equations, we get 25x is 70, which means x is equal to 70 upon 25, or which is the same as 14 by 5. And then the y coordinate is very easy, because that we can just use this x value here and we can get the y coordinate. So, the y coordinate will be 3y will be 16 minus 4x from here. So, that will be 16 minus 4 times 14 by 5, which is 56 by 5. So, that comes out to be, so 3y will be equal to 24 by 5, and therefore, y will be 8 by 5. So, the coordinates of the point of contact of the point where C1 and C2 touch each other is 14 by 5 comma 8 by 5. So, the coordinates of the point where they touch each other is 14 by 5 comma 8 by 5. So, but that only solves one part of the question, because it was also asked to, we were also asked to find out the equation of the transverse common tangent. So, let me draw the, so the transverse common tangent is basically a tangent like this, which is a tangent to both the circles. So, the same tangent is a tangent for this first circle as well as for the second circle. So, obviously, that has to be perpendicular to this line joining the two centers of the circle. So, it will be something like this. So, it will be perpendicular to this straight line drawn in black, and it will also pass through this point of contact, whose coordinates we have just found out now. So, this green line is basically the transverse common tangent, and for finding the equation we do not have to do anything much, because if we if we go back, then this was the line equation of the line joining the centers of the circle, and if we see the slope of this line, slope is equal to 3 by 4, which we had already calculated here. Now, the slope of the line perpendicular to this line joining the centers will be minus 4 by 3, because we know that the product of the slope of two perpendicular lines is minus 1. So, therefore, we know that the slope of this must be minus 4 by 3. And interestingly, if we see this equation here, this is also some equation of some straight line. because it is a degree 1 equation in x and y. So, this represents a straight line. The slope of this straight line is also minus 4 by 3, and we already know that this point of contact satisfies this equation. The point of contact is also on the tangent, and therefore, it is clear that the equation of this green tangent or the transverse common tangent is nothing but this straight line equation, because the slope of this straight line equation is also minus 4 by 3 plus this point x y, which is on the tangent, is satisfying the coordinates of this point is satisfying this equation. So, therefore, the equation of the transverse common tangent to both the circles is 4x plus 3y equals 16. So, that finishes the solution to the first problem, and here you might be wondering whether, because what we saw in this problem was that interestingly the equation of the transverse common tangent in this scenario where the two circles touch each other came out to be nothing but the difference of the equations of the two circles. But is that true in general, or maybe it was just a luck by chance for this particular example with these numbers? So, it turns out that this is true in general. So, let me quickly present that result. So, let us say that we have two circles here which touch at this point, and let us say these are the centers of these two circles and they are touching at this point. Let us say that the equation of the, so this is the first circle. So, the equation of the first circle is, so I will represent the first circle by S1. So, this is the equation of the first circle. Sorry, so I will use something else here. I will say O1 and O2 for the centers, because I will be using C1 and C2 in the equation for these two circles. So, the centers are O1 and O2. So, this is the first circle S1, this is the second circle S2, this is the equation of the first circle, and this is the equation for the second circle. So, now what is asked to us is to find out the equation of the transverse common tangent, which I have drawn in green. So, obviously, the centers of these two circles are minus G1 comma minus F1 for the first circle with center O1, and the center O2 for the second circle is minus G2 minus F2, and this is the straight line joining the two centers. Let the coordinates of this point of contact be x comma y, then it is clear that this x comma y satisfies both these equations. Now, since it satisfies both these equations, it must also satisfy the difference of these equations. So, if I take the difference, what I get is 2 into G1 minus G2 into x plus 2 into F1 minus F2 into y plus C1 minus C2 equals 0. So, the coordinates of this point of contact x comma y satisfies this equation, which is actually this is actually a straight line equation. This is basically the equation of some straight line. We will show that this equation is nothing but the equation of the transverse common tangent. So, one thing that we know is that this point of contact x y lies on the transverse common tangent, and this x y satisfies this equation. But what needs to be checked is whether the slope of this equation, if this equation has to be the equation of this tangent, the slope of this equation must be equal to the slope of this tangent. Now, the slope of the line joining the two centers is equal to f1 minus f2 by g1 minus g2, because this follows from the coordinates of the two centers. So, this is the slope of the line joining the centers of the two circles. Now, because the tangent is at 90 degrees, the product of the slope of the tangent with this slope must be minus 1, that is and therefore, the slope of the tangent is minus g1 minus g2 by f1 minus f2. Now, if we go back and see this line equation here, it is clear that the slope of this line is also equal to minus g1 minus g2 by f1 minus f2, and this shows that the equation of the common tangent is nothing but this equation, which is basically the difference of the equations of the two circles. So, let us take another problem related to common tangents between two circles. So, in this next problem, it is given that the centers of two circles C1 and C2, each of unit radius, are at a distance of 6 units from each other. Let P be the midpoint of the line segment joining the centers C1 and C2, and let C be a circle joining the centers of. Now, let C be another circle touching these two circles externally, but it is touching in such a way that a common tangent to C1 and C passing through P. So, this common tangent is also a common tangent to C2 and C. So, what is said in this question is that we have two circles of unit radius C1 and C2 as drawn here. Let us say O1 and O2 are the centers, and the distance between the two centers is 6 units. The midpoint is denoted, midpoint of this line segment O1 O2 is denoted by the point P, and then it is said that there is another circle C which touches both these circles C1 and C2. So, let this be circle C, and it touches C1 at this point and C2 at this point, and let us say that this is the center O of this big circle U circle C. So, if we connect these centers by a straight line, then this straight line will obviously pass through this point of contact, or the point where these two circles touch. Similarly, the straight line joining O1 and O will also pass through this point here, where the two circles C1 and C touch each other. And then it is said that there is a common tangent to C1 and C which passes through P. So, it cannot be this tangent here, because there is obviously one tangent like this. This is like a direct common tangent to C1 and C, but this obviously does not pass through P. So, the other case could be that we have a tangent like this So, this red straight line is a common tangent to both C1 and C. So, this is a direct common tangent to C1 and C, which passes through P, and further this is also a tangent to, this is also a common tangent between C2 and C. So, this is C and this is C2, and it was said in the question that the same common tangent between C1 and C, which passes through P, must also be a common tangent between C2 and C. So, that is what we are seeing here. So, since this red straight line is a common tangent between C2 and C, this angle must be 90 degrees. These two angles must be 90 degrees. So, let the radius of the circle C, which is what we have to find out, be r, and this is of course 1 unit, and this radius here is also 1 unit. So, if we look at the triangle O1 O2 O, the sides, two sides are of the same length, r plus 1, equal to r plus 1. So, this side is also r plus 1, this side is also r plus 1, and therefore, this is a isosceles triangle. Hence, if we, and since P is the midpoint of this side O1 O2, if we connect P and O, it is clear that the angle O2 PO will be 90 degrees. Now, we know that since P is the midpoint of O1 O2 and the length of O1 O2 is 6 units, it is clear that O2P is equal to 3 units. Let this point of contact be denoted by S. Now, we see that this triangle O2PS is a right angle triangle, and therefore, this length PS will be equal to, from the Pythagoras theorem, 9, which is the square of this hypotenuse, will be equal to the square of PS plus 1, and therefore, the square of PS is 8, and hence PS is square root of 8 units. Now, what we also see is that because this red straight line is a tangent, is a common tangent between C2 and C, the triangle PSO is also a right angle triangle. And in this triangle PSO, we have one side of length r, the other side PS is square root of 8, and therefore, the hypotenuse OP will be equal to, again by the Pythagoras theorem, square root of r square plus 8. Now, going back to the triangle, then considering the right angle triangle OPO2, which is this right angle triangle OPO2, we see that OO2 square is equal to, because this is the hypotenuse, O2P square plus OP square. Therefore, now OO2 is R plus 1. So, OO2 square is R plus 1 whole square, which is equal to O2P whole square plus OP whole square. O2P is 3 units, So, square is 9 plus OP square is from here r square plus 8, that is and therefore, r is 8 units. So, the radius of this circle C is 8 units. Let us take the third question. So, in this third question we have two circles, each of radius 5 units, and they touch each other at this point 1 comma 2. The equation of their transverse common tangent is given to be 4x plus 3y equals 10, and the question is asking us to find the equation of both the circles. So, the situation is like this. We have two circles which have the same radius, which is 5 units, and they touch at this point. The coordinates of this point is 1 comma 2. Let this be the straight line joining the two centers, and the transverse common tangent, which is this blue straight line, has equation 4x plus 3y equals 10. So, one can check that this point 1 comma 2 satisfies this equation, because obviously the point where these two circles touch has to lie on the transverse common tangent between these two circles. So, we already know the radius of these two circles. If we can somehow find the coordinates of these two centers, then writing down the equation of these two circles will be easy. Now, we know that the tangent makes an angle of 90 degrees with this straight line joining the two centers. The slope of this tangent is minus 4 by 3. So, slope is minus 4 by 3. From this it follows that the slope of the straight line joining the centers must be 3 by 4, because the product of the slope of these two lines perpendicular to each other has to be minus 1, and the slope of this tangent is given from here. We see that the slope is minus 4 by 3, and since the product of the slope of this tangent and this line joining the centers has to be minus 1, it follows that the slope of this line joining the centers must be 3 by 4, and therefore, the equation of this now let us say that the coordinates of the first center here is a comma b of the first circle. So, then it follows that since this is the slope of this line segment is 3 by 4, it follows that b minus 2 divided by a minus 1 equals 3 by 4. So, from here we can say that b minus 2 is 3 by 4 times a minus 1. Further, this length between O1 and the point of contact here, which is 1 comma 2, this is nothing but the radius of the circle, which is 5 units, and therefore, the squared radius, which is 25, will be equal to b minus 2 whole square plus a minus 1 whole square, but b minus 2 whole square can be written in terms of a minus 1 whole square using this equation. So, this is equal to 9 by 16 into a minus 1 whole square plus a minus 1 whole square. So, if we solve this equation we get a minus 1 whole square equals 16, which implies that a is equal to 1 plus minus 4. So, therefore, we have two values for the x coordinate. So, in fact, these two values will correspond to the x coordinates of both these centers, because the second center, the center of the second circle is also at a distance of 5 units from this point of contact. So, the coordinates of the center of the second circle must also satisfy this equation, and therefore, it follows that the coordinates, the x coordinates of these two circles are. So, for the first circle the x coordinate will be, so let us say 1 minus 4, which is minus 3, and the x coordinate of the second circle will be 1 plus 4, which is 5. And now, if the x coordinate is minus 3, which is a, then it follows that the y coordinate, which is b, we can use this equation, will be, so b minus 2 will be 3 by 4 into, this goes up here, 3 by 4 into minus 4, which is minus 3, and therefore, b will be equal to minus 1 for this point, and for this point it will be 5. So, now we have the coordinates of the centers of these two circles, and we know the radius to be 5 units, and therefore, the equation is easy now. So, the equation of the first circle will be x minus 3 whole square plus y minus 1 whole square is equal to square of the radius, which is 25. And similarly, we can write down the equation of the second circle. Next, we consider another little problem or another little topic of finding the common chord. So, next we discuss this topic of finding the common chord of two intersecting circles. So, the situation here is that we have two intersecting circles like this. So, when we have two intersecting circles, we have 2 points where they will be intersecting each other, and if we join these 2 points by a straight line, this line segment is a chord for the first circle as well as for the second circle, and that is why this chord is called a common chord of these two intersecting circles. Now, suppose that the equation of these two circles, so this is S1, this is S2. So, let us say the equation of the two circles are as follows. So, we are given the two equations of these two circles. How do we find the equation of this common chord? Now, suppose that let us say that these two, the coordinates of these 2 points of intersection. So, let us say that the coordinates of these 2 points are, for this point it is a comma b, for this point let us say it is c comma d. So, both these points a comma b and c comma d, so a comma b will also satisfy these two equations, c comma d will also satisfy these two equations. Now, because a comma b satisfies these two equations, it means that A comma B must also satisfy the difference of these two equations. So, when we take the difference of these two equations, we get this equation. Now, this equation is the equation of some straight line. Now, clearly A comma B must satisfy this equation, because A comma B satisfies both these equations. Similarly, C comma D, which is the other point of intersection of these two circles, will also satisfy this equation. Now, what that means is that both these 2 points essentially lie on this straight line, and since the straight line segment between any 2 points is unique, it follows that this straight line segment or this common chord has the equation which is nothing but this equation. So, this is the equation of the common chord of the intersecting circles. The length of this common chord is not very difficult to find, and we can quickly derive or see how to find it. So, let us say that O1 and O2 are the center of these two circles. So, let us say that this point of contact is P, or this point of intersection is P and this point of intersection is Q. This is the straight line joining the two centers. Now, it is not very difficult to show that this common chord and this straight line not joining the centers will be perpendicular to each other. They will be perpendicular to each other. Let us say this point here is M. So, since this line joining the centers is perpendicular to this chord PQ, what we also see is that this triangle O1 QP is an isosceles triangle. This is an isosceles triangle because O1P and O1Q are nothing but the radius of this circle S1, and because isosceles triangle and because O1MP is 90 degrees, it follows that M is the midpoint of this chord PQ. And since M is the midpoint of this chord PQ, the length of the chord PQ will be equal to 2 times the length of PM. Now, finding PM will not be very difficult, because if we see this triangle O1PM, it is a right angle triangle where O1P whole square is O1M whole square plus PM whole square, and therefore, PM is square root of, now O1P whole square is nothing but the squared radius of the first circle, which is, let us say, R1 square. So, from this equation we have PM equal to square root of O1P whole square, which is R1 square, minus O1M whole square. So, now we just need to find O1M. If we find O1M, then we can find PM. But finding O1M is very easy, because O1M is nothing but the perpendicular distance or the length of the perpendicular from this center O1 whose coordinates are known. So, since we are given the equations of the circles, the coordinate of O1 is known to be minus G1 comma minus F1. So, this coordinate is exactly known to us because the equations of the circles are known. Further, we also know the equation of this chord, which is this. So, then this O1m is nothing but the length of the perpendicular from this known point to this known straight line PQ. So, it is nothing but the distance between this or perpendicular distance of this point from this straight line, which can be easily found out, and that is our O1m. And then from there, since we already know the radius of this first circle, the radius of the first circle will be known from this equation here, which is given to us. So, then we can find Pm, and then we just have to multiply it by 2, and then Pq, the length of the chord, is just twice of Pm. With this, we come to an end to this lecture. In the next lecture, we will start a new topic, and we will discuss how to find the angle of intersection between two intersecting circles. We will find the conditions under which this angle of intersection is 90 degrees, and we will also define something known as the radical axis between two circles. Thank you.